That's our core product, the Qlustar operating system. And for management and setup of any kind of clustering and Linux machines. And it has a special communication architecture that I'm going to put some focus on later on. So I'm going to start with a short introduction, general introduction to Qlustar. Then I'm going to emphasize a little bit on our core operating system image technology that's used for booting computers or storage units. Then I'm going to talk about our management infrastructure system, which is called Qlustar. And finally, I'm going to emphasize a little bit on the communication architecture that is used by Qlustar underneath. So what is Qlustar? It's a full-fledged cluster operating system actually for HPC, storage, and public cloud workloads. So it supports Ubuntu, Debian, and from version 9.1 coming next year, at the beginning of next year, it's also Red Hat compatible. It's a complete Linux distribution, actually multi-Linux distribution, since we support, as I said, different distributions like Debian and Red Hat and Ubuntu. It's actually an official Debian derivative since some time, and it adds about 200 plus software packages, especially related to clustering, like Offset, InfiniBand, Stack, MPI, Slurm, Luster, HA. It all comes packaged out of the box in the system. One's on standard x86 46-bit hardware, compute, storage, GPU nodes, very easy to set up, extend, operate, and monitor. I'm going to do some details later. And very special thing is our extensive bioinformatics software stack that comes from our partnership with the Debian Mate community. And of course there is professional services and support by Qleap, the company that develops Qlustar. And the product itself, Qlustar, is only about 2 years old now, but it evolved actually from a system called Qleap VioBox that's already like 12 years old, and incorporates all the experiences that we had from a collaboration with a specific hardware vendor. And it's installed on many clusters, like a couple of hundreds. And yeah, you wouldn't know it under this name that we have now. So before I go into more general things, I will talk about the highlights of the newest 9.0 release. It will be out like next week or the week after. Didn't quite make it for a show here, but we have the philosophy that we release when it's ready, not when the show is on. So one main feature is that we have a new version of our management architecture. So that's Qlustar 2.0. It has a very powerful new command editor for executing parallel shell commands and analyze them, and also a very nice host filter for custom commands. It has a new fancy Slurm configurator that you can get a consistent, nicely set up Slurm configuration. It has graphical node monitoring now in this version. And then on the feature side, on the HPC feature side, it has first support for BGFS parallel file system that comes out of a partnership now with ThinkPark, the company that is commercializing the BGFS file system. And it has Luster 2.6 now on ZFS. We're using actually Luster on ZFS for a year now in productive systems very successfully. Has a brand new Slurm 14.11, just out a couple of days. And a lot more new stuff, of course, and it's based on, as core architecture, on Ubuntu 14.04, just release, long-term release that came out this year. So, a couple of reasons why you use Qlustar, apart from the pure technical points. Well, first of all, you become hardware vendor independent. I mean, these days, when you buy a cluster from some integrator, oftentimes they have their own better or worse cluster management stack. If you use Qlustar, you can just, on any cluster you buy, put the same software stack, so that allows for a homogeneous software environment. And of course, management environment across different clusters. And so there is no need to retrain stuff with every new system that comes in, because management system is different, another slightly different stuff. Also, the same thing applies to the users. For software development, they can rely on the same environment on many different clusters, time over time again. So it saves them a lot of work and gives them reliable results. And it's a freely downloadable product actually that distinguishes us from practically any commercial software stack in this area. There is a basic edition that is free for academic use as well. It supports full updates of the operating system, so you're not stuck like with many installed clusters with an outdated software stack that after 2 years basically tools are not really usable anymore and users are not happy. So it has a much better return on investment. It's open, 99% open source, packaged, all packaged with the source coming with it. Missing 0.1% is actually the management architecture, Qlustar. That's the only package that is not open source. And from next version on, it's actually evolving into a complete all-in-one cluster platform, where we support also OpenStack and Ceph, MapReduce, Hadoop type of workloads, and NoSQL databases like Cassandra. So let's have a more deeper look at what distinguishes Qlustar also from other systems. Let's look at some criteria that I would put as important for a true cluster operating system. So first criteria would be, does it have a single software package source? So that's true for Qlustar. There's a repository in the internet that you can get all packages from, so no need to go anywhere else. Of course, some commercial software you have to get from commercial vendors, that's clear. But that's usually not the case with provisioning systems. There you have a base distribution and the operating, the cluster operating stuff is then just put on top of that. So you have to go to multiple sources for that. And all system software is packaged in Qlustar, even the images as image modules. I'm going to talk about that later on. Also not the case in provisioning systems. That leads to reproducible and version installations, because everything can be reinstalled by just going back to older package versions or cleanly updated by normal operating system package mechanisms. Then we have a single source of security updates. Some of the importance of that I think is clear to anybody, especially this year after Heartbleed and shell shocks that we had. So we have security advisories like any other Linux distribution sent out and immediately available. And as mentioned before, it's consistently updated as well. Very important thing, so you're not stuck with old software. So what advantages does that bring to you overall? So it means that your clusters are actually much easier to maintain and operate and update. There's less source of errors, and of course, since things are cleanly set up, much simpler to support and debug. So let's talk about the imaging technology a little bit more in detail. Now, the point is that apart from the head nodes, no other nodes in the cluster are ever installed with this. So there is this concept of no provisioning doesn't exist in Qlustar, because nodes actually boot a lightweight RAM disk, so the operating system always runs in RAM on any normal compute node. The RAM disk itself is minimal, generated by a very sophisticated image generator from image modules. So we have a core image module packaged as an operating system package, versioned as well, and that is actually an operating system package that contains the full basic operating system for a compute node. So booting that image already gives you the basic stuff for any compute node, and then you can add on additional feature modules like InfiniBand or Luster or whatever you need for your particular workload. So, as I mentioned, there is no installation on disk ever, apart from the head nodes. Of course, the stuff has to sit somewhere where it comes from. Local disk, if you have some in your compute nodes, or in case of storage nodes, of course, is then used for scratch, bar, log files, local ones, and so on, or in case of storage nodes for object storage targets. Or, of course, you can run diskless by definition, because the operating system is in RAM. So that comes for free in this case. So let's have a little, let's take a little time to look at how images are actually created. I already mentioned that we have image modules that come as operating system packages. I have a little screenshot here from a listing of the package modules, core module, HA module, etc., etc. So you see some version number, some build number actually on the version, and they are pre-made actually and part of the basic repository of Qlustar. So from those then, you would, in the management graphical user interface, you have a dialog where you can actually now configure your final image out of these modules. So you select a flavor, in this case you want to precise some Qlustar version, 8.0, and some UnitFS group. I'm going to talk about that later. Actually nowadays it's called UnitFS change root in the current interface. And then, most importantly, the modules down. The core module, of course, that's the basic part of the operating system for a node. That's must always be included. But then you have just the option here to include different modules selected here in the GUI. Here like offset, Qlustar, and HA. Then you do the write, and the image is generated then for you on the fly. And the point is, this is really completely reproducible mechanism. So customer A in the United States is going to have exactly the same image out of this as customer B in Europe or wherever. So that's very important to get a reproducible, manageable system. So, oops. So, out of these modules now, as I said, the image is generated by the image assembler, and finally the standard node image is created out of that. So what happens now when you boot an image? Since the operating system is never installed, you have to boot via network, via Exhibitor. So the computer storage node is requesting a DHCP address from the head node, the standard mechanism really that most people use these days. Then the image is transferred via TFTP. Machine boots the Linux kernel mounted as a root file system. And then you have the final node image booted. And there's one additional mechanism here that actually allows you to have customization of what is really running in your operating system, and that's this additional UnitFS level. Images, of course, they are pre-configured, so there is not that much to customize. I mean, there are some runtime customizations that you can do, but in order to get any library or any program for all the users that you have to support, you need something more flexible. And that's what this UnitFS layer here is for. So put underneath the actual image by this UnitFS mechanism is a change root coming from NFS. It's not performance critical, that's why NFS in this case is okay. But in that sense, when you actually look and log in on a node, it has a full featured stuff that is coming from the image, plus all the packages that are normally installed in this change root. So even though you're transferring 100 or 200 megabyte image to your compute node very flexibly and fast booted up, you have actually a full Linux installation, matching Linux installation available on the node immediately via this change root. Yeah. So let's switch to Qluman now, the management platform of Qlustar. It's the basic thing that you mostly as an administrator are in contact with when you operate a cluster, like Qlustar cluster. So it's a central point of control. It's multi-user and multi-cluster. So multiple users at the same time can manage the same cluster. You can, from the same interface, manage multiple clusters as well. So in that case, multi-user, multi-cluster. It has a modern graphical user interface based on Qt and a unique remote execution engine. I'm going to talk about that a little bit more in detail. That's the graphical parallel shell. It's of course best demonstrated in live at our booth. I would be happy to come by and I can show you more detail about it. It has real-time updates of system changes. That means if user A is working on the same cluster and does some changes, before those changes are actually committed, the same changes will be shown in the open graphical user interface of user B. So any administrator working on the same cluster will always have a consistent view of the configuration that is actually active. It's also very important so people working at the same time are not annihilating stuff the other one is doing. And it's of course complete in-house development from scratch. The mechanism underneath, I mean, I'm talking about the architecture a little bit later, the mechanism underneath that we use for communicating between the different components is actually using efficient, reliable messaging based on 0 and Q software, and that actually makes the whole architecture really totally scalable. Important point, of course, for large clusters. So that's roughly how the architecture simplified looks like. So we have, like here, the admin workstations where the administrator works on with this graphic user interface, connects to the cluster. Then we have here the head nodes, the heart of the cluster, and the compute nodes. So the main thing, the main component really of Qlumen is this admin service here. That's kind of a message broker that any other component connects to and redistributes tasks and to the other components. So like the Qlumen database, where all the configuration is stored in the database, and the execution daemons that are then talked to by the remote execution engine that I mentioned previously. They actually do the work then that needs to be done, like writing configurations to file, or actually doing some execution of commands on the compute nodes. So that's how the basic architecture works together. And it all underneath the communication works with reliable messaging. That's what I'm going to talk at the end. There is a very powerful configuration management within Qlumen. So we have, of course, the basics of it is the host database with the IP, MACs, etc. of hosts shown here in this enclosure view, the MAC addresses and so on. And here you can actually sort. Okay, I want to talk about it later. So the host templates come first. The host templates are actually the most simple thing, the most simple way of providing a configuration for a node. The host template that's shown here actually consists of the config set, generic property set, and hardware property set. So combining all these sets assigns properties to a node by which it's then fully configured and which is as a property together and as a host template then assigned to a node. Since this sometimes is still too general, there is also the possibility to do actually simpler assignment of properties to host to override this general thing. So you don't have to make a template like for any slightly different node. You can say, okay, they are all basically the same, but they have some stuff different. So that's small stuff that is different. You can actually do by specific assignment as well. So it's a hierarchical structure how you can assign properties to your nodes. Yeah, that's what I already mentioned. And then, of course, you have physical management as well for rooms, racks, and hosting closures where you can put your nodes in. All that shown. So there are some screenshots that I did here. I go through these real fast because it's better to show actually on the live system on there. So that's how you would select the host template to some nodes, and actually an operating system upgrade, for instance, would just consist of assigning a different host template to a node. So you would pre-configure a new host template, assigning a different image, etc., etc. Then you assign that new host template to your host. You reboot the host, and you go from Ubuntu 12.04 to 14.04 within a reboot. So that's a very simple and powerful mechanism. This here is a dialog actually to add new nodes. There is a DHCP scanner by which you can very conveniently add unknown hosts as well from the MAC addresses. Then I have here quickly shown the dialog by which you write configuration files. The nice thing here is that before you write, you actually get always a diff if there are some changes to from the version that is actually in the database to the one that would be written. So you have a final control before you actually write changes to the disk. Because if you work in the GUI, you first do the changes just in the database. Nothing actually happens to the cluster yet. Only when you do the final writes for the configuration files that are written on this, then changes will become activated. And for that, you have actually this dialog to check what is really different now when you do the final write. And then, as mentioned before, you have this remote execution engine that has now a very powerful command editor. So you give a command some name. Here you give it visibility, saying what users and what roles can actually execute this command. That's always Qlustar users, admin users. Then you can say where should it be executed according to some host filters. So you can say, okay, this command should only be executed on nodes that have a host tag XY, for instance. And then you can insert here, you give that host filter a name. By that you have a command that is always executed on the nodes with specific properties, for instance. But here you can type in your command where you can actually substitute some arguments as well, depending on properties. So that's a very powerful way. I mean, you can put in simple things as well, but you have the option to really create very customized commands to execute on all Qlustar nodes exactly this command according to that and that condition. So it's pretty powerful. That's then the execution window that comes up where they actually do the execution. So once you've selected a command, it will show you what nodes it will execute, what command it will execute, and this we had already in the previous version, a very powerful thing, it actually analyzes the output of the commands that are executed on the computer. So it analyzes the output, it groups it then in node groups where the output is the same. So if you execute a command where you know the command should always have the same output, you should just get one group here. If you have more than one group, you already see something has gone wrong. But it goes further than that. Also shows failed commands, which have an exit status of 1 in a separate group. It shows nodes which had errors, that means something written to standard error as well. So with this you can really analyze a parallel command very, very conveniently, and instead of having a long listing with command line parallel shells, you can immediately see where something has gone wrong. Okay, let's come to the last topic now, that's the communications in Qluman. The basics of all the Qluman architecture is really reliable and scalable messaging, plus guaranteed delivery, because all of that is important in the cluster. So I'm going to detail that a little bit soon. It's important for consistency of the cluster and reliability, because if you've done some changes on the computer, if you executed some commands, you need to be sure it has actually been executed and whether it was successful. So that's what's also part of the execution engine that I showed you before. And of course, in large clusters, you need a very highly efficient and scalable mechanism to communicate between the different components. The next thing is then if you want to talk to clouds over the internet, you know that the internet is lossy, so you need something that controls your communication and makes sure that commands really get to where they should get to. So that is a real challenge, and you need a good messaging mechanism for that. So an example would be you do a parallel execution of a command on, let's say, 1,000 nodes or so, then you need to account for node failures and always possible in large clusters like this, network package loss, etc., etc. And of course, as mentioned before, an efficient analysis of the output of these commands and status in node. So the basis of this communication architecture is 0MQ really. It's actually open source messaging software, where here I compare it to properties that the standard UDP, TCP mechanism of communication have. I mean, UDP, of course, has no real reliability. It's partly scalable, but in principle completely unreliable. TCP, on the other hand, is reliable, but only on the bytes level. So you actually have a connection-oriented communication via a socket, and it guarantees delivery of the bytes, but you can't be sure about the order that things are delivered. And what we are interested in is that we deliver actually full messages in a complete sense. And that's where 0MQ then comes in. So it has reliable transport on the message level. Message being not just bytes, but actually objects that are being transferred. It's fully scalable because it has actually this concept of a 0MQ socket, which is an asynchronous message queue. and it's reliable as well. And what we have added as an additional add-on, actually also submitted upstream to the ZeroMQ project, is also guaranteed delivery by having actually heartbeats and a mechanism to be sure that the message has actually been received by the client. So that's important for controlling the housing. So this mechanism is used, for instance, for writing communication files. Blooming GUI, you say do the write, and then goes to the exit daemon, it says okay, etc., etc. So that's the workflow. Last topic now here is the thing about security within Qlustar. So all transport between all components is A, encrypted, and B, authenticated by certificates. And the mechanism used within CMQ is the so-called curve CMQ. It's based on curve CD. That's actually a mechanism that is way more secure than SSL. It's not that widely used yet, but it has a lot better based on elliptic functions. It's actually much better in encryption than the standard methods. So what's being used there is public-private key certificates for encryption. So all the components in the architecture are actually using that, and we're using encrypted communication from that. It has perfect forward security, because it's not like SSL, you have a fixed key. In this case, the keys are actually negotiated for each session individually and also. And also it has authentication with public keys, so there's no weak password problem. And finally, that leads to the fact that there are actually no replay, man-in-the-middle hijacking attacks possible. So that's, of course, especially for secure cloud computing, that's a requirement. Okay, that's basically it now. I'm just going to talk a couple of seconds about what Qleap, the company that providing Qlustar, can do for you. Of course, we develop Qlustar and provide support for it. We do cluster consulting, so independently of hardware vendors, we actually help you design a performant and powerful cluster hardware architecture for standard servers. We provide turnkey cluster solution with partners. And finally, we do also HPC application support for different commercial codes, etc. Okay, thank you. That was it. And please come by at our booth.
Ciao,